Yeah. Hi all. Good evening and welcome back to the ninth week of TA live sessions for AI KRR. And first of all, is my audio clear and is my screen visible?
Yes, sir.
Okay, thanks for confirming. So to address one question in the chat, um, Priya, the trend that I have observed is being followed by the main TAs of the course is that they are not sharing the answers to the graded assignments. And if you have a doubt, basically, Bhaskaran sir, who is the lead TA, he has said that students can rework the solutions from these partial solutions or the final answer given to them after the due date has passed. If they have doubts, they can share their partial solutions and then he will help them out, address whatever doubts they have. Okay, so that is a trend that has been followed, and for further queries you can look up the discussion forum and see if there are any discussions relevant to this over there. Coming back to the live session, so today we'll be discussing some questions from week 9 of the course, and yeah, without any further delay, let's get started. So we'll be discussing questions related to DL or descriptive logic, right? So the first question says that in DL, ALC stands for which of the following? So this is a recall based question. If you have seen the lecture slides, you might recall this. So which of these options is relevant over here? D, that's right. So thanks for your solution. The correct answer would be attributive language with complement. This is a simple recall based question from the lecture. So yeah, straightforward. I hope this is clear. Let's move on to the second question, which says that in DL, which of the following formulas denote concepts? So you might recall from the lectures that there are things like concepts and roles in DL, right? You can think of concepts as sets, and then roles are like functions. Okay, this you can think of this informal analogy in your mind, and based on that, which of the following do you think denote concepts in descriptive logic?
Sir,
Yeah.
sir, I don't know how to complete assignment, sir.
Which assignment?
Sir, this assignment, sir. How to complete assignment, sir? I don't know how to complete it, sir.
So to answer the assignment, you have to go to the Swayam portal. You can go through these videos that are here. Okay, you can
Video
watch all.
only display, sir.
Sorry.
Sir, the video only appearing, sir. But assignment question with answers not appearing, sir. Online quiz.
Yes. So every week the assignments have a due date. Okay, and
Okay, sir.
you have to submit your answers before that due date. And once the due date has passed, the answers will show up over here. Okay. For example,
Okay,
if
sir.
from the previous week, if you look at the assignment,
Sir.
just a minute. Yeah, so here you can see the answers are given over here. So then you can try to rework your whatever solution that you had put up and verify against the provided answer. If you have any doubts, you can go to this Q&A option over here. Click on this.
Q&A option, sir.
Yes, you can click on this,
Why, sir?
continue.
You have to click on search, sir, for Q&A.
You can see the point where I'm moving my cursor over here at the top. Okay? You can go over here. This will lead you to a discussion forum, and here you can ask your doubts. See, many people have asked their doubts here. You can also see your doubts over here. Okay, coming back to the question. So any partial solutions, any guesses on which of these will denote concepts? So I'll give you a hint. Whenever there is a subsumption, um, that is a giveaway that it has something to do with a role, not a concept. Okay, let's go over the options.
C. C.
Okay, so we have a vote for option C. Let's go over the options one by one and see which of them are concepts. Okay, so the first option says that for all has sibling dot rich. Okay, this basically represents the set of all people who have a sibling and rich, and who satisfy the attribute rich. Okay, similarly option B gives so you can think of a sort of as an intersection of the set of people who are teens and people who are happy. Okay, and then option C represents the set of all people who are not doctor. Okay, the last two options though, these are uh, not concepts, these are roles. Okay, so let me just try to explain that. So you see, this is a good example over here. These boxes are the different concepts. Okay, and then these small circles, these are like roles connecting the different sets to each other. For example, this says that so this big box represents the set of happy people. Okay, and then there is this role called owns that connects it to the another set that is represented by apple. So this basically represents that people who own an apple are happy. Okay, so whenever we have something like this, we can say that it's not a concept, it's a role. And this is also given by the subsumption operator, which is this. So whenever this is present, we can say that it has something to do with a role instead of a concept. So the correct options here would be A, B and C. Okay, if there is a slight confusion over here, it's okay. We'll be discussing some more questions related to concepts and roles, and hopefully that will help you clarify some of the doubts that you might be facing.
So in the same way, sir, I understood, but still,
Hmm.
I can link A and D, right, sir? Has sibling, has brother is a role you say,
Yeah.
and overall has sibling. Okay, so that is a set.
Yes.
Okay, yes, sir.
Has sibling is like a set of all those people who have siblings.
Okay,
Yeah.
okay, sir. Thank you, sir.
Okay, then let's move on to the third question. So the third question deals with the NNF form of this particular statement given over here. So what is an NNF? Let me show that to you. So NNF is basically negation normal form. Okay, and in the negation normal form, a formula has to have only this and or negation. Okay, only these connectives are possible, and a negation occurs only before concept names, not before role names, right? So whenever we are given a formula and if we have to convert it to a negation normal form, we should convert equivalence to this simplification, and then we should convert all subsumptions to this thing. This is like an implication, sort of, you can think of it in that way, not of C or D. Okay, so now coming back to the question, if we have to simplify this to the simplest form, the non-negation form, the negation normal form, or NNF, which of the following options do you think we'll obtain? I'll let you try to work it out, and then maybe in a minute we can discuss the solution.
Sir, I'm very sorry to disturb, sir. I have the same doubt with respect to question number two, sir. In
Okay.
question number two, sir,
Uh-huh.
has sibling In the D option, you said that has brother is a role. Am I right, sir?
Has brother is a set,
Ah,
has friend is a set, but these
yeah.
two sets are connected by this role over here.
Okay.
Because of this small circle that we see. Yeah, so because of that we can't say that this whole thing is a concept. It should.
Concept.
Yeah.
Okay. Okay, sir.
Okay.
Answer C.
Okay, there's one vote for our option C, but I'll give you a hint. See if we can further simplify option C. Notice that there is a negation before a there exists in option C. Can we further simplify that?
Yes, yes, sir. D option D will be
That's right.
confirmed.
So the correct option will be option D. And for and how that is, let's try to debug that. So the first thing that we do is we simplify this equivalence, okay? And for that,
Yeah,
that is represented by option A over here. We basically say this teen and there exists owns dot apple subsumes happy, and then the other way around, right? And then we simplify this subsumption operator by replacing it with a negation of the first part or the second part, and similarly for this part of the formula as well. Then we move the negation inside, which is what happens in option C over here. And then finally in option D we move the negation to the deepest level, right? And this is the simplest form that we can get, and this is the NNF form of the given formula. Okay, any doubts there? Okay, if not, then that's great. Let's move on to the next question. So here we are given a statement that we saw in the previous live sessions as well. The statement is some apples are red, and we have to represent it using the correct description logic representation of the statement given to us. So which of these do you think would be the correct representation of some apples are red in description logic? Remember, we are dealing with description logic. So the kind of reasoning that we followed to arrive at an answer in the first order logic in previous live sessions will also hold here.
option A.
So option A says that apple and red subsumes. So this is the bottom operator, right, which represents false.
So
But
false means it includes at least one, no, sir?
no, so basically we have to find a representation of this statement. Some apples are red. And in order to find this representation, we have to assume that the statement is true, right? So basically this
Okay.
represents the set of some entities that are apples and some entities that are red, and the intersection of those two sets should be
The
true.
question answer B.
Option B, sir.
That's right.
B.
So the correct option will be option B. Okay, all other options are false by the reasoning that we just discussed. Now let's look at an alternative version of the statement given to us. Okay, in question 5 we are asked to select the correct representation of all apples are red. So which of these do you think would be representing all apples are red?
Answer C.
Option C, that is correct. because option C represents apple subsumption operator red. This basically translates to anything that is an apple is red. If apple, then red. You can think of it in different ways. All of them give the same statement, which is all apples are red.
So this is equivalent to implication, no?
Yes. I mean the domains are domain in the sense the framework is different. Here we have description logic. There we had first order logic. But yeah, you can draw that analogy and say that this is similar to an implication. Okay, then I hope there are no doubts here. Okay, we can move on to the next question then. So here we have a slightly more complicated statement. Okay, the statement tells us people whose all children are vaccinated are proactive. Okay, so read the statement carefully and then try to find the correct representation of this statement in this description logic. I'll give you a couple of minutes to think about it.
Option B.
Okay, we have one vote for option B. We have another vote for option D in the chat box. So I'll give you a hint. So what this statement basically tells us that it's similar in spirit to the previous question that we just discussed. Okay, because it says that people whose all children are vaccinated are proactive. So there is an all over here, right? So there should be a for all operator somewhere, right? Now who to whom does for all operator apply? It applies to those people whose all of their children are supposed to be vaccinated, right? And then we categorize all those people as proactive. Okay, so there has to be an intersection between the set of all people and the set of people whose all children are vaccinated, right? There might be people whose all children are not vaccinated. Maybe only one of the child is vaccinated, or only two of the children, or none of the children are vaccinated, right? So we have to find an intersection between the set of all possible people and the set of people who have children and all of their children are vaccinated, and then we categorize all these people as proactive. So now, which option do you think would be correct?
B, sir.
B. So I think we have multiple votes for option B, and that is correct. Option B is the correct option over here.
Sir, what is the meaning of answer A?
Answer A says that people, the intersection, the set of people, basically the intersection of the set of people and the set of people who have child and all of those children are vaccinated is equivalent to the set of people who are proactive. This is not what the statement conveys. So proactive, the set of proactive people might contain people who are other than people basically whose all children are vaccinated. Do you get my point? So let's say another criteria to say that people who are proactive are people who exercise daily. So there might be another set of people who exercise daily who are also categorized as proactive, but that doesn't mean that anyone who is proactive also has to have all of their children vaccinated. That is why option A is incorrect.
Yes, sir.
Okay.
Thank you, sir.
Okay, then any doubts in this question? If not, then that's great. Let's move on to the next question. So here we are given a knowledge base. Okay, some facts in the knowledge base are given to us based on some concepts and some roles. Okay, and we have to select which of these following options are true. The options basically give us different facts that can be entailed by the knowledge base. Okay, and the facts given in the knowledge base are that the person named Ada is a doctor, person named Bob is a doctor, and person named Eva is a doctor. And then Ada has a child named Bob, Ada has a child named Eva, and then Bob has a child named Tom. Okay, so which of these do you think would be entailed? I'll let you think about it and then we can discuss the solution after a couple of minutes.
Answer B. Okay, yeah, sorry for the delay. So I see there are a couple of votes for option B, which is in fact correct. So option B is the correct entailment, which says that um, Ada basically belongs to the set um, where which is an intersection or not an intersection actually, but the set of people who have some children who is a doctor. Okay, and that is what is represented by the knowledge base over here. Ada has a child named Bob and Bob is a doctor. Ada has a child named Eva and Eva is a doctor, and Ada herself is a doctor as well. But there is this extra information on the fact that Bob has a child named Tom and we don't know anything about Tom. Okay, any doubts there? Sir, had child Ada above means Ada had child above, yeah, Ada is child of above. What does it mean, sir?
I think it means Ada has a child named Bob.
Ada has a child.
Has this example been covered in the lectures? Then maybe we can verify it from the lecture slides.
Okay, sir.
Um, do you remember if this example has been covered in the lectures? Okay, I don't think so. It has been covered. Anyway, yeah, I think it means that Ada has a child named someone. But yeah, let me also think about it. If the answer changes, I'll keep you posted in the next live session. I'll inform you. Okay.
Okay, sir.
Okay, then let's move on to the next question then. Okay, so this is question 8. Okay, and here we have a Venn diagram sort of different concepts. Okay, the figure shows a domain that has many individuals, but for the sake of simplicity, we have shown only 6 of them that are represented by I, J, K, L, M, and O. Okay, so each of these alphabets represent an individual. And furthermore, the subset relation in the figure holds in all interpretations of the domain. What that means is the overlap shown in the different boxes in the figure over here basically denote the set and subset relation among the different concepts over here. Okay, and now we have to identify the statements that are true based on this figure and the sort of placement of the different boxes and the overlap between the different boxes that we can observe over here. Okay, so I'll give you a couple of minutes to go over it, and then we can discuss the solution. In the meantime, feel free to post your solutions in the chat box or unmute yourself.
Option A and D.
Okay, we have a vote for options A and D. What about the other options? So I'll give you a hint. Only one of the options is incorrect. Okay, we have another vote for options A, D as well as C in the chat. What about P and E? So I'll give you another hint.
B is of course wrong, sir.
Okay, B is, so there we have one vote that says B is wrong.
E only we have doubt. And D not the, it means what?
Basically, it means the intersection of the sets dean and author.
Okay.
If author is not a bridge player, then how the intersection will be true?
True. Yeah. E will also be true.
So bridge player, the set of bridge players is the one that is slightly bluish in cover and towards the back of the all the Venn diagram, all the subsets given, all the boxes given in the diagram, right? And then this intersection between the set dean and set author is the square at the center in which that individual k is placed,
Yeah.
right? And you can see that that small square in the center, that is completely surrounded by the area that is
Bridge
occupied
play.
by bridge player. Yeah, exactly.
Yes, sir.
So
So
option
only B is wrong.
That's right. So the only incorrect option is option B. All others are correct options. Let's just quickly go over all of the options just for the sake of completeness. So the first is only professors can be deans, um, which is true because the set of professors is bigger than the set of deans and it covers all of the individuals in the set of deans. Okay. Authors are bridge players. This is incorrect because of this small part of the set of authors that extends beyond the set of bridge players on the left and right hand side of the set of bridge players. Okay, the part that I am just showing by my cursor over here, this part and this part. Okay, some authors are bridge players, that is true. Um, authors is a subset of well read, that is also true. And then the last option we just discussed, so that explains all of it. Okay, coming to the next question. Here again we are given a knowledge base and we have to select the correct entailments. Okay, so let me just go over the facts in the knowledge base. The first fact is parent is equivalent to those people for whom there exists at least one child, and this is true basically. And then ODC is equivalent to all those people who whose all children are doctors. Okay, so basically ODC corresponds to all doctor children. Okay, PODC is equivalent to the intersection between the set of people who are parents and whose all children are doctors, so basically parents of all doctor children. Okay, and then finally we have a fact which says that Max has a child named Amy, and then Max is basically belonging to the set of ODC, or only doctor children. So based on all these facts, we have to select the correct entailments. So again, I'll give you a couple of minutes to think over it and then we can discuss the solution. So to address your query in the chat, Kushagra, so this course is offered alternate semesters. So next semester the course that will be offered will be Search Methods for Problem Solving by Professor Khemani. After that semester this course will be offered again. So usually this course is offered in the Jan to June semester, and then the other course is offered in the July to December semester.
Sir, option C and D. No, B and D.
Okay, we have vote for options B and D. Okay, so remember the fact given to us is that Max has a child named Amy, and we know that
Max has all doctor children.
yes. Um,
So I'm easy, a doctor. No?
okay, so Amy has a child named Amy, and we know that Max has all children. Yes.
doctor. No?
Um, okay, so Amy has a child named Amy, and we know that Max has a child named Amy, and we know that Max has all children. Yes. Um, okay, so Amy has a child named Amy, and we know that Max has all children. Yes.
that should be true. Okay, let's go over the options one more time. Okay, so the first option says that parent Max, which is pretty clear, right? So this says that Max has a child named Amy, so Max is a parent, so that is true. um, then the second option says that um, parent of only doctor children, right? So this ODC basically represents the set of all people which have, for all children, they are doctors, right? And we are also given that only doctor children Max. So
Max is parent of all doctor children.
that is also true. And then Amy is a doctor is also true. But this part we cannot prove,
No.
right? Because we are not given any information about whether Amy has
Um,
any children or not.
yeah.
So that's right. The correct options are A, B, and D. And the only incorrect option is option C. I guess that's straightforward. So, yeah, that actually brings us to an end of all questions for today. This is a pretty easy week, so not much questions to be framed from here. Is there anything else that you would like to discuss over here before we close the session for today?
So, question number 2 alone, can you explain once, sir?
Okay, let's go to question
N
number.
and F.
Okay. Okay, let's try to work it out step by step on the whiteboard. Okay, so this is the formula given to us. Sorry for that. And now we want to expand this. Let me extend this. So the first thing that we do to expand something, so when we have something like A is equivalent to B, we can simplify this as A subsumes B and B subsumes A. Okay, this is how we expand equivalence. Is this part clear?
Yes, sir.
Okay, and then we simplify a subsumption operator further using, so if we have something like A, sorry, subsumes B, so this we can write as negation of A or B. Okay. Okay. Now with these two in mind, let's try to simplify this further. So the first step that we do in simplification is to resolve this equivalence, and for that we will write this. Okay, so the first part says that teen and their owns dot apple subsumes happy, and this becomes the first part, and then the second part becomes happy subsumes this whole thing, teen and their owns apple. Is this step clear?
Yes, sir. Yes, sir.
Okay, so next what we try to do is we simplify each of these subsumption operators, And to do that, we uh, do the simplification as discussed and arrive at this formulation. So basically we replace this by a negation in front of the first part, which is this thing, and then or happy.
Yes, sir.
Similarly for the second
Yes.
part. Next what we do is we push this negation all the way inside, right? So this will become not of teens, this and will become an or, there will be a negation in front of this there exist owns dot apple, right? And then this will remain or happy, and this will also remain as it is, right? That is what is shown over here. Okay, this step is clear.
Yes, sir.
Now the only simplification that we can do is this part where we can replace this negation of existential operator
But
uh,
universal.
with the universal operator,
Yes.
and
Yes.
that is what is there in the final option over here. So this becomes the correct solution.
Yes, sir. Thank you. Thank you so much, sir. Thank you, sir.
Oh, sorry, this was question 3. You had asked about question 2, right?
No, sir. No, sir. I wanted the NNF only, sir.
Oh, okay,
Right.
okay. Okay, cool, that's great. Anything else?
Sir, from week 8 assignment, question number 16, sir.
Week 8, question number 16. Okay, when you treat the above RDF document as a knowledge base, what can be inferred from it? Okay, let's look at the knowledge base. So this says that book is a class, person is a class, man is a subclass of person, woman is a subclass of person, parent is a property, mother is a sub-property of parent, and father is a sub-property of parent, and Ada is a mother of Bob, Ron is the father of Bob. Okay, fine. We can infer that
Sir, what is the way to infer? I
so
don't know.
if you remember last time we had discussed that this basically whenever something starts with a small alphabet, this is kind of like a relation between two sets. Okay, so mother is basically a relation that connects some set to another set. Okay,
Okay.
father is similarly a relation that connects some set to another set. Now here okay, let's go back and refer to the slide from last time to see um, what we had there. Okay, this is not that. Huh. So here we had something like Rang, poet Amir Khusro. So Rang is a song that has been written by Amir Khusro. So poet is the relation connecting the set of songs to the set of people or poets. Okay, this was an example from last time. Now let's come back to this question over here. So it seems like this mother is a relation connecting the set of the set that represents the set of woman to the set of person, and then father represents a relation from the set of man to the set of person. Okay, so okay, first let's say the accepted answers. Ada uh, is a parent of Bob. Okay, that is inferred, that is true, because mother is a sub property of parent, right? So that makes sense. And man is belonging to the type class, that is also true. But what I don't understand is why are the first two options not correct? This should be correct, right? Because mother connects a set of women to a set of people, and then the other way around for father as well? Is it because this is not specifically told to us? Let's have a look at the lecture slides.
Is there any procedure to easily find out the answer?
There is no specific procedure as such that I am aware of. Oh, actually, we would find that in week 8 itself, right?
Yeah.
Okay. Okay. So every property has to have a domain and a range. That is given over here. Now let's see whether that is specified in the RDF given in the um, example uh, in this slide.
I have not given an example how to infer.
So I mean, we can rely on our understanding of the English language, but that's what I'm not entirely sure about. That's why I wanted to confirm whether it has to be explicitly specified in the example. What is the range and domain? See, it has to be explicitly specified. Poet has domain song. Poet has range poet. That's why we can easily say that poet is a relation from song to poet. That's why we could infer that over here. But in this assignment, um, sorry about that. Yeah, that information about the domain and range of the property is not given to us. So although based on the English language we know that mother will obviously represent the relation from the set of women to the set of people, we can't can't enforce that because that is not explicitly specified to us in this RDF document. Right? That's why the first option is incorrect and the second option is incorrect. Did that answer your query? Am I audible?
Yes, sir.
Okay. So, any doubts in this question that you had just asked? Should I explain it once more?
Yes, sir. Once more. Yes, sir.
Okay. So, basically, what is given over here, let me write this in a white box. This is the RDF document given. Okay, this is what is given to us. Sorry about that. Yeah. If we had this extra line over here, similar to okay, not this. Over here, something to this if we had. So let's say over here, let me use a different color to denote that we don't actually have this information given to us in the example. Okay, can you look at this? Is this visible?
Yes, sir.
So if we had this specified that the subproperty mother's domain is woman and range is person, right? Similarly, if we would if we were given that, okay, they should also be red colored. Okay, if this was given to us, then we could infer that. So basically what this would represent is that something like this. So this is a set of women, people who are women. Okay, this is a bigger set of people who are just persons. Okay, and then there is a set of people who are called man. Now this kind of relation from woman to person, where this will represent mother. Okay, I'm not writing the whole thing. This would mean
Yeah.
that there is a relation between this set of women to the set of people, which basically means that uh, a woman basically can be a mother to any of these people belonging in this set, which is kind of shown in this example, right? So Ada belongs to this set, and Bob belongs to this set, right? Bob could also belong to the set of male, but we're not given any information, so we'll just assume that it's as of now not classified. And then Ada is the mother of Bob. Okay, similarly Ron is the father of Bob, so Ron will be over here, and there will be some relation like this. But because we are not given this information that is there in this red text over here, we don't know what is the domain and what is the range of these relations. That's why we cannot infer the fact that Ada is a woman. Okay, because we cannot categorize Ada as to belonging to the subset of women. Does that help?
Okay, sir. Yes, sir.
Okay.
Adult woman. One is a man.
Any other doubts?
Sir, what is the difference between T box, R box, and A box?
Sorry, a difference between?
Sir, T box, R box, and A box.
This is from which week?
Sir, week 9.
Okay.
From DL language.
Yes.
Okay.
I'm trying to find the.
Next slide.
So it says that the description logic language can be categorized as sentences. These sentences are made up of axioms and assertions. So axioms in turn would be made up of concepts and roles. Okay, concepts would be following in the T box, roles will be falling in the R box, right? And then assertions again themselves have concepts and roles, and these would be falling in the A box.
So then what is the difference between axioms and the assertions, sir? First.
Yes. So here we are given the definition. So knowledge base is a set of sentences, axioms and assertions. T box is a set of axioms, R box is a set of role axioms, and A box is a set of concept and role assertions. Okay, let's look at this example. So knowledge base is made up of T box, R box, and A box. T box says that the set of people who are teen and who own an apple, they are happy. Okay, fine. And then role is like has brother is a subset of or is subsumed by or subsumes has sibling, right? So has sibling is a bigger set and has brother is a smaller set. And then the assertions So you can think of it in this way, okay? This A box essentially consists of the instances or elements inside each of those sets, okay, or subsets. So T box basically consists of the different factual accounts or sort of the generalized rules, you can say. And then R box consists of all the relations or functions connecting those different sets to each other. And then A box consists of all the elemental instances of all those different sets. Like if we draw the diagram like we just drew, there was a diagram here as well, right? So this basically represents that um, this big set was a set of all people who are happy, right? And this is a set of all people that are basically all the things that are apples. So this owns operator connects the set of people who are happy to the set of apples. So this conveys the line that uh, people who are owning an apple are basically falling in the set of um, happy category, right? And
Yes, sir.
so this kind of a rule is followed is falling in the T box. This relation is falling in the R box, and there's this individual instance. For example, this Lucy, this is an instance in this set of happy people. So this Lucy will form our form an element of our A box. Does that help clarify this to some extent?
Sir, A box.
So this represents a set, right? This thing in this T box, this is
Yeah.
representing a set. That you agree?
Yeah.
Okay. This is representing a relation between sets. That you agree?
Yeah.
And this is representing one element belonging to one of those sets.
Yeah.
Does that give an idea?
Yes, sir.
And similarly, this is also kind of an instantiation of the role, right? This is an instantiation of the concept. This is an instantiation of this is also a concept basically. It basically says that Lucy has a brother named Jack. Okay.
Sir, what is axioms and assertions, sir? What is the meaning? How can we differ?
Axiom is something that we assume, and assertion is something that we assert. Like basically we put a value to it. So basically, when we say that Lucy is happy, we are saying that Lucy is belonging to the set of happy people. And when we represent the set of happy people, we just assume that any individual who is belonging to that set is supposed to be happy.
Okay, sir.
I know it sounds quite abstract, but yeah, just give it some time and it should get familiar. If not, you can ask for more examples on the discussion forum.
Okay, sir. Thank you, sir.
Okay. Anything else? Okay, if not, then maybe we can close the session for today, and we can meet again on Tuesday next week. Okay.
Thank you, sir.
Thanks all for attending. Let's meet next week.